Hey calculus kids, this is Dr. Callahan with Week 7 Wednesday. How are you guys doing? Let's go ahead and get started with today's notes. So looking at this part right here, go ahead and pause the video and answer the following questions for your warm-up. All right, let's go ahead and create the assignment for those of you guys who have this class hybrid at home. So today is going to be Week 7 Wednesday. This is your instruction along with the links that you will need for this class. Today, we're going to continue on from what we talked about on Tuesday, which is the derivative of tangent inverse functions. Yesterday, we went over examples 1 to 3 and then 4 and 5, but I feel like we need to continue on with 5, 6, 7, and 8. And so our topic of discussion today is going to be on derivatives of arc trig functions. And so let's go ahead and put that here. This is for AP Calc AB, semester 2. Okay, make sure you guys check in with me by the end of second period, which is 9:41. That's when I generally take the attendance for the class. And if you're doing this at home, make sure you upload your assignment so that way you get points and credit for it. And I'll just go ahead and cite it. In addition to this, you do have an assessment today on AP College Board. So my recommendation for you guys is make sure you do go on to AP College Board and complete that for week 5. I'm sorry, week 7. We're not going backwards, we're going forward. Come on now. All right, so let's go ahead and take a look at your first question for your example here. Here you're asked to find the derivative of e to the sine x cosine x, and given to you that x is pi and also y is 2. All right, so let's take a look at this. So it's given to you that dy over dx is this. So if my job is to go ahead and find the particular solution, in this case, what I want you to find is y equals mx plus b. That's your goal. I will have to integrate this so that way I can get rid of the dy over dx, and so it's just going to be y. So if I integrate the dy over dx, it's just going to give me a y with the integral of e to the sine x cosine x. Let's go ahead and do a u sub with this, okay? And so when I do the u sub, I'm going to say let u. And with u, you probably wanted to have that b up there because you know the integral of e to the u is just e to the u plus c. So just keep that in mind. So I want to rewrite this so I just have e to the u. So I'm going to have my u be sine x. Then from there, du is going to be cosine x dx, and then dx is going to equal to du over cosine u, or at cosine x. All right, so then y is equal to integral e to the u times cosine x. Replace your dx, you have a du over cosine x. And lucky for you, we can cancel that out, which is perfect. So y equal integral e to the u du. And you know that the integral of e to the u is just e to the u, which e to the u is e to the sine x plus c. So at this point, let's go ahead and plug in the x and the y right here. So y is 2 is equal e to the sine x is pi plus c. Let's go ahead and solve for c. What is sine pi going to be on the unit circle? I believe it's 0, so e to the 0 plus c. E to the 0 is going to give you a 1. So then C is equal to 1. And there you have it. So if I rewrite this, y is equal e to the sine x plus 1. And that is your equation. All right, let's go ahead and take a look at this. Derivatives of inverse trig functions, just keep in mind, you're going to switch the x and the y, solve for y, and just read the following. Yeah. All right, let's go ahead and move on today. This is a breakdown for your lesson today. Take a look at what we're going to be talking about. Your guided note today looks like this. This is your first page. Second page from your textbook. Third page, fourth page, and fifth page. All right, so we're going to go ahead and go back to week 7 Tuesday's notes because we did not finish that. And so let's continue with that then. So we're going to go to right here. So once again, continuing our notes on derivatives on trig inverse from yesterday, week 7 Tuesday. I ended you guys with example 5. So let's go ahead and take a look at example 5. Okay. So example 5, remember there are two ways I ask you guys to do this. You can either do this the long way, which is you don't need to memorize the formula, or you could do it the short way, but you do have to memorize the formula. So let's go ahead and do this then. Okay. Remember there were several steps. I believe there were 3 steps specifically. Step number 1, you're going to go ahead and just put tangent on both sides, okay? When you do that, tangent arctangent cancels, and now you have tangent y equals 4x. Step 2, find the derivative of this. What is the derivative of tangent? Secant square y. Because you're finding the derivative of something with y, you have to put a dy over dx. And the derivative of 4x is just 4. Now let's go ahead and step 3. Solve for dy over dx. Dy over dx is equal to 4 over secant squared y. Which is equal to, another way of writing secant squared y is just 4 cosine squared y. And then remember initially from your equation, what is y equal to? Y equals arctangent 4x. So let's replace that y with 4 cosine squared arc tangent 4x. And you're going to be working this from the inside, okay? So remember examples 1 to 3 from yesterday's notes. You will have to draw that triangle and continue from there, okay? So you're standing from the perspective of this person right there. Opposite, hypotenuse, adjacent, and you're looking at this from tangent 4x, okay? So tangent is going to be adjacent over opposite, or I'm sorry, opposite over adjacent. No, I'm sorry, no. Yeah, so your opposite is going to be 4x, and then your adjacent, I'm sorry, it's opposite over adjacent, duh, and that's going to be 1, okay? So then how do you find your hypotenuse? Your hypotenuse is going to be the square root of opposite squared plus adjacent squared. So putting numbers into this, 4x squared is 16x squared, 1 squared is just 1. So now that you have hypotenuse, opposite, and adjacent, you can now go back and work on the outside of this. Okay, so for the outside of this, you have 4 on the outside, cosine squared, okay, because there is a square right there. So what is cosine? Your cosine is going to be adjacent over hypotenuse. So your adjacent is 1. Hypotenuse is a square root of 16x squared plus 1. And don't forget the square in the bracket. And of course, if I go ahead and plug that square in, 1 squared is just 1. And then in the bottom, your 16 is going to be freed because a square root with a square cancels itself. And this is your answer, 4 over 16x squared plus 1. Okay, so if we were to go ahead and go back to this and kind of review and think about, okay, how do we go about getting the answers for this? I would say, and I want to make sure I insert this in here so that way you guys can see it. I'm going to move this down a little bit. The steps are as follows. Step number 1, you want to make sure that you multiply tangent on both sides. Afterwards, make sure you find the derivative of both sides. Don't forget the dy over dx. Next step after that is you're going to solve for dy over dx. Oops. And then afterwards, you are going to rewrite the equation by substituting for y. And then afterwards, you're going to work from the inside out by drawing your picture, drawing your triangle. All right, and that, you guys, are the steps for this. And it's important to kind of have those steps so that way you know what it is that you're doing, what your goal is for this. All right, so then let's go ahead and move on to the next one. If I were to go ahead and do the short method for this, you would have to memorize the formula, unfortunately, and it's like adding 6 more to your current list of things to do. I personally just prefer not to add any more, and I would just go the long way. This is a shorter method, so you do need to memorize the formula. So again, this is the same example. It's for arctangent, and so, arctangent is going to be right there. Notice you need a u prime and a u squared. So it's going to be pretty simple. Let u be, well, it's in the parenthesis, 4x. Then u prime is 4, and u squared is going to give you a 16x squared. So you know y prime is equal to, take a look at this formula, u prime over 1 plus u squared. So then if I were to just go ahead and replace this, u prime is 4, whoops, 1 plus u squared, 16x squared. And take a look at that. That is literally exactly the same thing that you just did, except it's a shorter method. But you have to memorize the formula. All right, let's go on to example 6. Let's try to do the long method with this one. All right, so with this one, first step. you are going to go ahead and put in the secant for both sides. Secant y equals 2 secant arc secant 3x squared. That part cancels. Secant y equals 2 times 3x squared. See, sometimes it's actually kind of nice to have the steps over here so that way you can see it. Okay, so I'm going to go ahead and just take this and copy it over so that way I have it. Oops, this is not correct. Wait, is this correct? No, that's correct. Example 6. Sorry, I'm going to go ahead and grab this. Cut, move it over to example 6. Paste. Let's make this a lot smaller. Cut. Okay. Sorry about that. I just had to move it over a little bit. All right, so we're now going to multiply tangent. We're going to go ahead and multiply by secant. So obviously we did that. Derivative of both sides. Okay, so the derivative of secant x is going to give you, a secant y and tangent y, dy over dx, which is equal to the derivative of this part, which is 6x squared, which is a 12x. Okay, so then we go ahead and solve for dy over dx, which gives me a 12x over secant y, tangent y. Okay, as I'm looking at this right now, if I had to replace the y, this is going to look extremely, extremely ugly because I'm going to have a 12x over, because my next step is to replace the y's. So secant y, I'm going to replace that y with a 2 arc secant 3x squared, and then tangent 2 arc secant 3x squared. Oh my gosh, that's going to be kind of crazy. Because how am I going to proceed with this and find that? So at this point, I'm like, dang it, maybe I should not do that. So in which case, you could try to do the easier method, which is to go ahead and memorize the formula. So here it's an arc secant, and so let's find it. Your arc secant is me using this formula right here. And you will need to have a u prime in addition to a u squared. So let's give that a try and see, because this one looks extremely ugly if you're going to use the long method. So with that said, we're going to go ahead and try this. So let u, well, obviously your u is 3x squared. Your du is, or excuse me, not du, your u prime is going to be 6x, and then your u squared is going to be 9x to the 4th. Now that you have these components, let's just do this. Y prime is equal to u prime over absolute value of u square root u squared minus 1. So y prime is equal to u prime, which is going to be 6x over absolute value u, so 3x squared, square root u squared, which is 9x to the 4th minus 1. And that's it. That looks a whole heck of a lot easier than what we just went through. Okay, if we were to do this with a more difficult method. All right, you guys, so that is basically it. I would like you guys to go ahead and try example number 7. Let's go ahead and take a look at example number 7. Okay, so for example number 7, I'm not even going to attempt to do the long way because that seems extremely long. Let's go ahead and just try to do the short way. So looking at this one, you're looking at arc cosine. So this is the formula you're going to need. If you're looking over here, you know you're going to use u prime and u squared. So looking at this, let's go ahead and before we do the let, because there is a multiplication here, so you have to use the product rule. So f prime, or excuse me, f is going to be equal to x, f prime is 1, g is going to be arc cosine 2x, so then g prime, so arc cosine in this situation, g prime is going to be negative u prime over square root of 1 minus u squared. So with this situation, let's let u be 2x, u prime is 2, u squared is 4x squared. So g prime equals negative u prime, which is a negative 2, over the square root of 1 minus 4x squared. So going back to this, y prime is equal to, remember it's f prime times g plus f times g prime. So f prime times g is just going to be an arc cosine 2x plus f times g prime is going to be a negative 2x over square root of 1 minus 4x squared. And that is your answer for example 7. Let's take a look at example 8. I have the answers right here, so go ahead and give that a try on your own. Alright guys, as always, stay safe and healthy, and I'll see you guys next time.